good morning once again. Welcome to today's lab. Today we are going to treat unconfined compression test, and it's a modified version of the unconsolidated and drain test. So let's now go through the objectives and then get ourselves ready for the lab. So the first one says you should plot the axial stress versus the axial strain, and it's just like this. It's very simple. So we are going to have a sample that we exert a vertical pressure on it without any confining pressure. And once we get that, what we want to do is to make sure that we plot the axial stress that we are imposing on the sample versus the strain that will be experienced by the sample. And that's what the first point is talking about. So you can see the vertical stress against the strain. Alright. Then with that, we are going to determine the unconfined compression strength. And then that one we are going to determine in the graph of shear stress against the normal stress. And usually the QU is like the tip of the graph that we are drawing here. Right? So it's like the peak of it, the highest vertical stress becomes our QU, or the unconfined compression strength. And as we know, the strength is simply the highest stress that the sample can endure before failure. That's how come it becomes the peak of our graph over here. Alright, so going to the next point, that's the plotting of the Mohr circle and determining the and drain cohesion. All you have to do is to make sure you pick the unconfined compression strength, which is your QU. Then you come to the Mohr circle plot, and that's the shear stress versus the normal stress. And in that case, your unconfined compression strength becomes the radius with which you draw this Mohr circle, because as you can see, the confining pressure is 0. That's how come the sigma 3 is 0. Then this is the principal stress, which becomes your unconfined compression strength. Then you are able to draw the Mohr circle. And the half of this, okay, becomes our cohesion. That's how come when you see the radius of this circle becomes our cohesion. So we just take it straight from the graph. And this line is flat, or it is having a slope of 0 because the friction angle of the clay is assumed to be 0. Okay, so in this case, you have a friction angle of 0. And as you can see here on the board, my CU, or my cohesion, is the unconfined compression strength divided by 2, because it's simply the half of that. Alright, so number 3 asks us to determine the consistency of the soil based on the unconfined compression strength. And there is a table that we use. So basically, you have values of the unconfined compression strength, and you match what you got to the description of the properties, and you're able to get the consistency of the soil. And then number 4 asks us to draw a sketch of the specimen failure and determine the approximate angle of the failure surface. So as we continue to impose this stress on this sample, it will fail along a particular line that we call the failure plane. And sometimes it could be angle 45. So we are required to make sure we make notice of the orientation of the failure plane or the angle of failure. And that's what number 4 is simply telling us to do. Then number 5, you're supposed to determine the moisture content, the void ratio, and the degree of saturation, and which we've done repeatedly in this lab. So we are just going to go along and do that as required. Okay, so now we are at the practical section of the lab, and then this, as you can see, is my cylindrical mold, which will help me to mold the sample into a cylindrical form for us to be able to perform the test. And these are my calipers that I'll be using to measure the correct dimensions are taken of the sample. And this is my extruder. It helps me to extrude the sample from the cylindrical mold. This is my plastic plate, which helps me to keep the sample. Then this is my wire saw, which I'll use to trim the sample to the required shape. Okay, so now I'm required to put the clay inside the cylindrical mold and tamp it 10 to 20 times, but in this lab we are just going to stick to 15 times. So I've already added some clays, so I'll just go ahead and then tamp it. So I'm compacting my last layer, which is the third layer for this, and that's the same as the other layer, is to be 15 blows. So now that I'm done compacting the sample, we can see that part of the sample is actually extending beyond the cylindrical mold. So what I'm about to do now is to trim the sample flush with the tip of the cylindrical mold. using this device to extrude the sample. So now I'm taking the dimensions of the sample. Alright, so I have my diameter. I now have my height or length of the sample. So this is my GeoJag instrument, and then what I'm about to do now, as we've done in most of the lab, is to check to see if the instrument is well calibrated. And what we focus on are the two sensors. Then we have the deformation sensor, then we have the load cell. So I'll check to see if it's actually zeroed, and if it is not zeroed, then we just have to go into the computer and then re-zero it to make sure we bring it back to the mean position, so that any measurement we make is like coming from the mean position onwards. So we are required to make sure that the distance between the two platings is less than 2.3 inches, and I have done my measurement and I realized that it's actually correct. It's less than 2.3 inches. So I'm showing this. As you can see, the gap is closing, and I'll stop it right when it's at the top. Now the test is running. I've set my strain rate to 1% per minute, and then my strain limit is 15%. So it should take approximately 15 minutes for this test to be done, which means by the time I get to the 15% strain, I'm likely to get my failure. So now our test is done, and as we can see, we have the failure occurring. Okay, we can see the failure, and it's like almost a 45 degrees failure plane, and that's what we want, and our sample has failed. All right, so now that we are done with the test, as you can see, we have the failure planes. Okay, so what we do is to just, you can use your protractor or you estimate it and then find the angle at which it has failed, and that's what I did at the beginning of the test by illustrating this here. Now that you are done with your test, you just have to plot the vertical stress against your vertical strain, and then you take the peak, and that gives you your unconfined compression strength. Once you take that, you come and plot a more center, which is shear stress against normal stress, and the peak of that, or the half of that, actually gives you your cohesion. Thank you so much for being part of this lab. We hope to see you next time.